Hello everyone, my name is Shona McCaffer and I'm excited to talk to you today about my dissertation research project, Why Did the Albany Adder Cross the Road, or Did It? And this research formed part of my master's degree with the University of Edinburgh, but I was also fortunate to work in collaboration with the Endangered Wildlife Trust as well as with the BioNerds. So first, let me give you some background on the Albany Adder, Bitis albanica, which was only described in 1937. It is a dwarf adder in the viper family, approximately 25 centimetres in length, and it is endemic and restricted to inland regions of Algoa Bay in the eastern Cape of South Africa. And historically, it did occur in several distinct populations here, but is now reduced to just two sites. These declining numbers of populations is one of the main reasons the IUCN has listed Albany Adder as endangered on its most recent assessment. Additionally, these remaining sites are at threat from habitat destruction and degradation, particularly through limestone mining and wind turbine construction. And with this infrastructure, road traffic also appears to be a threat through direct road mortalities. However, there is very little information on this species, and in 2016 there were only 12 confirmed sightings, with no records added between 2007 and 2016, despite active searches, and at this time the Albany adder was considered likely to be extinct. Thankfully, this is when the Endangered Wildlife Trust became involved, and they began targeted searches at the last recorded location, and they were successful at finding a population. But detecting Albany adder has been very difficult, and almost all of the new records have been found whilst driving on the roads through intensive road surveys. So far, their project to avert extinction of Albany adder has focused on securing habitat through landowner agreements and engaging stakeholders on these private lands. However, since so little is known about the habitat requirements or ecology of the species, making conservation recommendations has been difficult. So this research aimed to bridge that gap, firstly by determining what habitat types Albany adder use, as this would influence targeted land conservation. Most recent sightings have been in grass-ridge Bonfelt vegetation, which is a sparse and low-lying habitat with bushy outcrops associated with a limestone substrate, which you can see in the top picture here. However, historically there have been sightings in thicket, particularly Sunday Valley thicket, which is a very contrasting, dense and almost impenetrable vegetation with tall spiny trees, as you can see in the bottom picture. Secondly, I wanted to look at conservation recommendations that could be made to prevent road mortalities, as well as getting some baseline data for future monitoring and to guide future research, particularly by assessing different detection methods. So briefly, the methods that I used were split into trapping and road crew surveys. I used pitfall traps with buckets dug into the ground, as well as double entrance funnel traps, and these were used in combination with drift fences, as you can see in the left picture. These trap arrays were randomly constructed in the different habitat types, and I recorded all captured species daily. For the road cruises, I surveyed roads using either a bicycle or car and recorded Albany adder as well as other snakes and any species of roadkill. And here's the map of the study site, where you can see the road network and habitat types. And this is located at a private wind farm and limestone mine, and it's where most recent Albany adder records are from. So the main part of the research used site occupancy modelling of the road network to account for the imperfect detection. And I considered various site covariates such as road edge habitat, road structure and associated land use as predictors of road occupancy. And for detection, I considered road structure, time of day, as well as meteorological variables. So for 23 days in October 2021, I surveyed these roads at least once per day, recording these covariates and noting any observations. And I found 6 live Albany adder. So all of these were associated with grass ridge Bonfelt vegetation. However, the occupancy models indicated that occupancy was more influenced by wider gravel roads than the vegetation types. And these roads also correspond particularly to the wind turbines and their access routes. As predicted, the detection rates were low, and this figure suggests that over 99% of Albany adder in occupied sites were potentially missed during the surveys. This detection was influenced by the time of day, with most seen in the late afternoon and evening, as well as reduced cloud cover, no rain during surveys, and more were detected on wider roads. So these results can be useful for road mitigation planning and further monitoring, which I will talk about a bit later. In addition, I looked at physical data for the 6 specimens. 3 were male and 3 were female, and this was the first data on lengths and body weights together. And you can see from the graph that it can start to shape a picture of the relationships between weight and length between sexes, which is important to understand life history traits such as adult size, as well as monitoring juvenile versus adult population structure and changes over time. I also looked at the behaviour of Albany adder on roads, particularly because all 6 were found in exactly the same position. They were all flat to the ground, close to the road edge, but facing towards the other side. And this is what started the debate of whether the Albany adder were crossing the road. So did they freeze when the car approached? This would seem likely as they are a cryptic species, and freezing would be a common method of not being detected by predators. But it seems odd that they were never found in the middle of the road or on the other side, and perhaps they are using the road as part of their ecology. They could be using roads as a source of heat or for basking. They could be foraging for live prey or scavenging for roadkill, and maybe they never cross the road at all. But to answer this question, we would need further research, such as spatial radiotelemetry. But talking of roadkill, I detected a total of 48, all of which were invertebrates. And using kernel estimates of intensity across the road network, you can see that the brighter coloured roads are the ones estimated to have higher numbers of roadkill on the left. And interestingly, this does correspond well to the kernel intensity maps of Albany adder sightings. And this could be useful for conservation planning because detection rates of Albany adder are so low that if we can use roadkill surveys across other taxa, these are likely to still show us the higher risk areas that can be targeted for traffic moderation. Now, as well as conservation recommendations, I also wanted to compare methods of detection for future research. But in this study, no Albany adder were captured in traps. Therefore, I used the data for all species of snakes that were either detected on roads or captured in funnel traps, as the pitfall traps failed to capture any snakes at all. So first, I compared methods across the vegetation types, and you can see from this bar chart the effort per hour between methods. And I found that funnel traps in thicket and road cruises in Bonfelt are by far the most efficient, and this can obviously help when planning studies in these different habitats. So finally, I compared the effort by time overall for detecting all species of snakes using either a bicycle, car, or funnel trap. And interestingly, the bicycle was the most efficient method compared to similar rates for the car and funnel traps. It was also more effective than the car at detecting roadkill, especially the smaller species. Now, there is some detection bias in terms of the different types of roads surveyed between the car and bicycle, but I think the increased visibility and stealthy approach of the bicycle meant that I could sneak up on more skittish species of snake. And as far as I'm aware, there are no standardized studies comparing bicycle and car roadkill detection rates, but this would be recommended based on these results. In conclusion, what does this mean for Albany adder and what conservation recommendations can be made? Firstly, as it's private land, we can restrict road traffic between 3 and 9 p.m. when they are most likely to be on the roads, as well as creating an awareness among staff of the locations they are more likely to encounter Albany adder. And using novel road signs like this one could be a useful reminder. Additionally, while Bonfelt vegetation is unlikely to be the only habitat Albany adder use, it still appears to be an important habitat for them, and measures to protect the few remaining sites should be a priority. Continued population monitoring through physical data, occupancy studies, and roadkill surveys will help to detect changes over seasons and years. However, further knowledge can help to secure a brighter future for this species, and one interesting outcome from this study was the increased occupancy at wind turbine sites. Wind turbine construction is seen very much in a negative light since they create footprints in the habitat and increase traffic. But maybe the wind turbines actually encourage occupancy of the species, and this study by Law et al. Found that attacks by predatory birds are reduced at wind turbine sites on adders in Scotland, and that wind farms may actually provide a sanctuary for snakes, and it certainly seems like this might be the case here as well. Additionally, understanding the relationship between Albany adder and roads can help to assess the risks not only of road mortality, but also the risk of creating fragmented populations with less resources or less chance of reproductive success. And spatial radiotelemetry studies would be a great way to assess movement patterns here. And lastly, searching for more populations of Albany adder can be aided by habitat suitability mapping, but should not be restricted to grass-ridge Bonfeld, as well as road cruising where feasible. The use of drift fences with camera traps placed in open funnels are proving to be less labour intensive than funnel traps and may be more efficient when searching for new populations, particularly in thicket. So thank you for listening to my presentation, and I would like to thank again the University of Edinburgh, the Endangered Wildlife Trust and the BioNerds for all of their help with this project. Thank you.